Question 1a, find the ratio of the number of pupils to the number of teachers. Give your ratio in the form n to 1. So ratio of number of pupils to teachers, well there are 840 pupils and 40 teachers. Dividing both sides by 40, 840 divided by 40 gives me 21. So a ratio of 21 pupils to every teacher. Part B, 105 pupils in Year 11 study chemistry. Work out the number of pupils in Year 11 who study physics. Well, if the ratio of chemistry to physics is 3 to 2, and we've got 105 pupils that do chemistry. Well, actually, 3 times 35 gives me 105, so times the other side by 35 as well, which leaves me with 2 times 35, 70. So there are 70 students who study physics. So the ratio of the number of boys to girls is 4 to 3. So in total we've got 7 parts there. 4 plus 3 equals 7. So if I do 105 divided by 7, which equals 15, so 1 part is 15. We want to work out the number of girls. Well, girls make up 3 parts, so 3 times 15, which equals 45. So 45 girls. 4 times 15, that would give me 60, which would be the number of boys. Just to check, 60 plus 45, 105, which is the number of pupils who study chemistry. Work out the area of the trapezium. Well, the trapezium has a formula, or area formula of half a plus b times h. That's on the formula sheet, where a and b are the lengths of the opposite sides, so 7 and 11, and h is the distance between. So we've got a half 7 plus 11 times 10, which equals 90. So the area of the trapezium, 90 centimeters squared. So now calculating the volume of the prism, well, we know that the cross-sectional area is 90. The volume of a prism is cross-sectional area times the length. So it'll be 90 times the length being this value here, 12. So 90 times 12, which equals 1080. There are several ways to answer this. One way is we could multiply out, rearrange, or alternatively, the method I'm going to show you, is if we divide both sides by 6, which gives you on the left hand side 3y plus 5, 39 divided by 6 is 6.5. Now subtract 5 from both sides, so I've got 3y equals 1.5, and hence divide by 3, which gives you y equals 0.5. 1.5 divided by 3 is 0.5. To find the mean number of goals scored, well, we need to sum the number of goals scored. So in 2 matches we have 0 goals, so 0 times 2, plus in 10 matches we have 1 goal, so 1 times 10, 7 matches 2, etc. So that's the sum of that gives me the total number of goals scored, and I know that that's in a total of 30 matches. So divide by 30, which would give me the mean number of goals scored per match, which is 2.13, and we can leave our answer like that. So to match shape P onto shape Q, well, it's going to be a rotation. It's going to be clockwise 90 degrees, and now we need to say the centre. If you use your tracing paper, you can find that the centre is 0, 0. So that's a rotation 90 degrees clockwise, centre 0, 0. Simplify k times k times k times k times k. Well, there are 5 k's there, multiplied together, so k to the power of 5. Expand, so I'm multiplying out the brackets. 2 times 70, 14t, minus 2 times minus 3, which is going to give me minus 6. Expand and simplify, so 4 times 2y, 4 times 6, so 8y, plus 24, minus 3 times 2y, minus 6y, minus 3 times minus 7, negative times negative is positive, 7 times 3, 7, 14, 21, so plus 21, 8y minus 6y, 2y, 24 plus 21, so plus 45. To expand these brackets, so I do x times x, x times minus 4, minus 6 times x, minus 6 times minus 4, so x times x, x squared, x times minus 4 is minus 4x, minus 6 times x, minus 6x, minus 6 times minus 4, negative times negative is positive, 6 times 4, 24. So that leaves me with x squared, minus 10x, minus 6 minus 4 is minus 10, plus 24. Simplify fully, v to the power of 4 times v to the power of 7 divided by v to the power of 5. Well, when I'm multiplying, I add my powers, so on the numerator, that's going to give me v to the power of 7 plus 4, which is 11, over v to the power of 5. I can write this slightly differently. So rather than as a fraction, I can write it using the division sign. That should be clearer. That you should see now that with division, we know we do subtraction. So 11 minus 5, which leaves me with 6. So v to the power of 6. In order to work out the area of the shaded region, I need to do the area of the circle, take away the area of the square. Area of a circle, pi r squared, where my radius, so the radius of the circle, is half the diameter, which is 5. So pi times 5 squared, take away the square in the middle, 3.2 times 3.2, length times width. That's going to give me, to 3 significant figures, 68.3. Expressing 825 as the product of its prime factors, well, we need to think of a number that goes into 85, so as it ends in a 5, it's therefore divisible by 5. 825 divided by 5 gives me 165. Again, this is also divisible by 5. 165 divided by 5, 33. 33 is divisible by 11. 33 divided by 11 is 3. All of these values at the end of my stems are prime numbers, so I can say that 825 equals 3 times 5 times 5 times 11, or alternatively 3 times 5 squared times 11. So the universal set is positive whole numbers less than 13, so that means not including 13. So the numbers 1 up to and including 12. A, even numbers, well the even numbers between 1 and up to including 12 is 2, 4, 6, 8, 10, 12. Multiples of 3, 3, 6, 9, 12. Prime numbers 2, 3, 5, 7, 11. Next one will be 13, but we're not including the number 13 in the universal set. List the members of the set A intersect B, or you could say that is A and B. So we're looking for everything that is in both the lines A and B, which is the numbers 6 and 12. B union C, alternatively you can read that as B or C. So I want to list every number that's in B or C, but not repeat. So 2, 3, I'm not going to write 3 down twice, 5, 6, 7, not 8, 9, not 10, 11, 12. Is it true that 14 is a member of A? That funny sign means is a member of. Well, it is a member of A because it is an even number. However, the universal set is whole numbers less than 13. So in this instance, it isn't a member of A. Reason being is that the universal set is numbers less than 11. Sorry, less than 13. The mean of 4 numbers is 2.6. So if I wanted to work out the total of those 4 numbers, 2.6 times 4, which equals 10.4. One of the 4 numbers is 5. Find the mean of the other 3 numbers. Well, if I do 10.4 minus 5, which leaves me with 5.4, and I know now that the other 3 numbers, not including 5, add up to 5.4. So the mean of those 3 numbers, 5.4 divided by 3, is 1.8. In order to work out which country has the largest land area, I suggest one method could be that we turn these numbers from standard form into an ordinary number. So 1.13 times 10 to the 6 is the same as 113, 0, 0, 0, 0. So moving the decimal point there 6 spaces. Again, moving the decimal point 6 spaces. So the land area of Ethiopia is 1,130,000. Algeria, 2,380,000. Nigeria, 924,000. Kenya, 583,000. So the largest land area is Algeria. Calculate the total land area in kilometers squared of all 4 countries. Well, if I sum the land area of those 4 countries, I get the solution 5.017 times 10 to the power of 6. Part C. One year the population of Ethiopia was 7.91 times 10 to the 7. Calculate the population density of Ethiopia for that year. Well, the land area of Ethiopia for that year was 1.13 times 10 to the power of 6. That was the same as the value on our table. 1.13 times 10 to the power of 6. So, population, 7.91 times 10 to the power of 7, divided by the land area, 1.13 times 10 to the power of 6. On your calculator, gives you the value 70 people per kilometre squared. Express the size of angle ACD in terms of x. If I zoom in, just give me a bit more space. I know that ABC is an equilateral triangle, i.e. that angle is 60, 60, 60. Therefore, this angle here is going to be 60 minus x. Equally, as this second triangle BCD is isosceles, I know that this angle here is also 60 minus x. 180 degrees in a triangle. So in order to work out that angle there, I'm going to do 180 minus 60 minus x. Take away 60 minus x. So that's 180, take away 60, effectively I'm multiplying this bracket here by minus 1, so that's going to give me minus 60 plus x, again the same here, minus 60 plus x, so that leaves me with 180 minus 60 minus 60, so that gives me 60 plus 2x, so this angle all the way around here is 60 plus 2x, so therefore this angle here, well that one must be 60 plus 2x, take away, which is 60 plus 2x is all the way around, take away 60 degrees. That's going to leave me with just 2x. So the angle DCA is 2x. So in order to factorise this fully, easiest thing to do, you could multiply out, easiest thing to do though is to spot they've got a common factor. So common factor being x minus 5. I'd have to times x minus 5 by 4 and also x minus 5 to get this first term here. X minus 5 times x minus 5 gives me x minus 5 squared. Obviously I need this 4 as well, so I also need to times by 4. To get the second term, x minus 5 times, that's just a 3. So 3 times that gives me this term there. Now the second bracket I can expand and simplify. So 4 times x, 4 times minus 5. Which leaves me with x minus 5, 4x minus 17. Peter wants to pass his driving test. The probability he passes on his first attempt is 0.7. So therefore the probability he fails, well, they're one of the only two, has to be one of those two options, must be 0.3. If he fails first time, then he has to try again. He'll either pass or fail. Probability of passing second time, 0.8. So therefore fail, 0.2. Calculate the probability that Peter needs exactly 2 attempts to pass his driving test. Exactly 2 attempts, so that means that he must fail and then pass. Probability of failing, 0.3. Probability of passing, 0.8. I'm multiplying, and probability means multiply. 0.8 times 0.2, sorry, 0.3 times 0.8, 0.24. Calculate the probability that Peter passes his driving test at his 3rd or 4th attempt. Well, to pass on his 3rd attempt, he will have failed, and then passed. To pass on his 4th attempt, failed, pass. And we've already said in probability means multiply, or means plus. Probability of failing, well, on first attempt 0.3, probability of failing second time round 0.2, probability of passing 0.8, fail 0.3, 0.2, 0.2, passing 0.8. Putting that in your calculator and you get the solution 0.0576. So if the farmer's got 120 metres of fencing, and we know all the other dimensions of the field, so x, y, then we know that 120 must equal x plus x plus x plus y plus y. Alternatively, I can rewrite this as 120 equals 3x plus 2y. And so taking away 3x from both sides. 2y equals 120 minus 3x, and finally dividing by 2, which leaves me with the solution. Y equals 60 minus 1.5x. Part 2. Show that a equals 60x minus 1.5x squared. Well, the area of the field is going to be x times y. So area equals x times y. Well, I know my y value, 60 minus 1.5 x, so a equals x times 60 minus 1.5x, multiplying out, and you get the area equaling 60x minus 1.5 x squared. Part B, find dA by dx. Well, we know a equals 60x minus 1.5x squared. Therefore, dA by dx, what I'm doing there is that means the differential of. So I need to differentiate this equation here. So bring the power to the front and reduce the power by 1. X is the same as x to the power of 1. So bring the power to the front. So the 1 times the 60 gives me 60. Reduce the power by 1, so x to the power of 1 minus 1 is 0. So just x to the power of 0, which is 1. So that just leaves me with 60. Minus, well, 2 times 1.5 is 3. Reduce the power by 1, 2 minus 1 is 1. So 60 minus 3x. Part C, find the minimum value of a. In order to calculate the minimum value is where the gradient on the curve is, the maximum value of a is where the gradient on the curve is 0. dA by dx is a posh mathematical way of saying gradient. So I want to find where dA by dx equals 0. Hence 0 equals 60 minus 3x. Add 3x to both sides. Divide by 3. So therefore, the maximum value, or the maximum value of a is when x is 20. We also know a formula linking x and y is that y equals 60 minus 1.5 x. So y equals 60 minus 1.5 times 20. So y is going to equal 60 minus 30, which is 30. So their maximum value of a, well, a is x times y, so 20 times 30, which equals 600. With histograms, the area of each bar represents the frequency. So I know that 28 customers represents that area there. Breaking that up, we have 6, 7, so there I've got 2 halves, making a whole. So I've got 7 5 by 5 squares there. So 28 5 by 7, which equals 4. Each of these squares here represents 4 customers. Now, if I want to estimate the number of customers who spent between 5 and 14, well, we want to work out this area here, plus this area, plus all of this area. In total, I have got 1, 2, 3, 4, 5, 6, 7, 12 whole squares, 2 halves, so that makes another whole. 13 whole squares, another 2 halves. 14, another 2 halves, say 15, another 2 halves. So I've got 16 of these 5 by 5 little squares. Say 16 times, we've said each square represents 4 customers. 16 times 4, which equals 64 customers. Calculate the length of AB when the hands show 5 o'clock. Well, first of all, if we were to calculate this angle here, well, I know I want 5/12 of 360 degrees. 360 degrees being all the way around. I want 5/12 of it. 12 hours on a full clock. I want 5/12 of a full clock. 5/12 of 360 gives me 150 degrees. Now if I redraw this triangle, so I've got a length of 10 and a length of 7, I know my angle 150 degrees, 10, 7, and I want to find this length. I'm going to call it length x. Well, I can spot here that I've got 3 sides, 1 angle. It's not a 90-degree triangle, so therefore I need to use the cosine rule. Found on your formula sheets, a squared equals b squared plus c squared minus 2bc cos a. Labelling the triangle, well, cos a, so the angle I know, I'm going to call the corner a, hence the opposite side a. B and c, it doesn't matter which way round I call them, so hence opposite sides, little b, little c. So therefore subbing in, x squared equals my b value squared, 10 squared plus c value squared minus 2 times 10 times 7 times cosine of the angle 150. Therefore x squared equals 270.24, keep all the values on your display, square root, and that gives you a value of 16.4 centimetres to 3 significant figures. 16.4 centimetres. So the length AB, 16.4 centimetres. So if the total area of the lawn on the path is 100 metres squared, show that 6x squared plus 7x minus 98 equals 0. Let's think about the lengths of the entire rectangle. So this length is going to be 2x plus 1. And horizontally, well, we've got 3x plus 2. Okay, so to work out the area, I can do 2x plus 1 times 3x plus 2. I know that the area of the lawn on the path is 100 metres squared. Multiplying out the left-hand side, 6x squared plus 4x plus 3x plus 2 equals 100. Hence simplifying, which is going to give me 6x squared plus 7x plus 2 equals 100, taking away 100 from both sides, which gives me 6x squared plus 7x, 2 minus 100 minus 98 equals 0. Calculate the area of the lawn. Well, to calculate the area we need to solve this equation, 6x squared plus 7x minus 98 equals 0. I'd suggest use your calculators. A value 6, B value 7, C value minus 98. If you sub those in, you get solutions for x to be minus 14 over 3 and x equals 3.5. Now the distance, because x is a distance, it cannot be a negative number, so the only solution for x is 3.5. Now in order to work out now the area of the lawn, we need to think about this section here, which has dimensions 3x and 2x. So therefore the area of the lawn, area equals 3x times 2x, say 3 times 3.5 times 2 times 3.5, which gives you an area of 73.5 meters squared. The size of the interior angle is 7 times the size of the exterior angle. Now we don't know the size of the exterior angle, so if I call that x, I do know now then the relationship between the interior and exterior. Well, the interior is 7 times the exterior, so I can call that 7x. 180 degrees on a straight line, so 7x plus x equals 180. 8x equals 180, so x equals 22.5. So the exterior angle, x, 22.5 degrees. Now we want to work out the number of sides, however. The formula that links the exterior angle on the sides, well, exterior angle equals 360 divided by n. So substituting into that, exterior angle 22.5, 360 over the number of sides, swap and drop, so n equals 360 over 22.5, which gives you an n value of 16. To show that 0.015 recurring is 1 over 66, first we start by saying x equals 0.0151515. The 1 and 5 is the only bit that's recurring. Next I want just the recurring pattern behind the decimal point. So if I times both sides by 10, I've now got just the recurring pattern. Ignore this top line now. Again, I want to keep just the recurring pattern behind the decimal point. If I times both sides by 100, okay, I've got the recurring parts behind the decimal point, and it's the same pattern. 10x times 100, 1000 x equals 15.151515. If I do the bottom line, take away the top line, well, 1000 minus 10, 990x equals, well, 15.151515. Take away the recurring part, so 0.15151515. Well, actually, the recurring part's going to disappear, and I'm left with just 15. So x equals 15 over 990, which is the same as 1 over 66. So we've started by saying x equals 0.0151515, i.e. the recurring decimal, and we finished by saying that x equals 1 over 66. We've shown that the recurring decimal is the same as 1 over 66. In order to calculate the upper bound in millimetres for the thickness of one sheet, well, we need to do the total height divided by number of sheets. That will give us the thickness of one sheet of paper. Now if we want the upper bound, then I need to make this one as big as possible, i.e. the upper bound of that value, and this one as small as possible in order to get the upper bound of the thickness of one sheet of paper. Now the upper bound for the total height, well, if I've got height of the pile is 160 millimeters, correct to the nearest 10 millimeters. So the way I like to do it, well, if we think of 160 to the nearest 10, below that to the nearest 10 would be 150, above that 170. So therefore the lower bound would be halfway between 155, upper bound again halfway between 165. The upper bound is the value we want, so 165 millimeters. Equally, 1,300 sheets, correct to the nearest 100, so 1,300. Below to the nearest 100, 1,200, 1,400. So here the lower bound halfway between 1,250, upper bound 1,350. I want the lower bound of the number of sheets. So therefore, in order to work out the upper bound for the thickness of one sheet of paper, total height, which is 165, divided by 1250, which gives me 0.132 millimeters. Solving a quadratic simultaneous equation, there are a number of steps which you can do the same thing every time. First of all, we're going to want to sub one equation into the other. This equation here, they've made it slightly more complex. We're going to need to rearrange. So I want to get to the point where y equals, so add y to both sides, minus 7. So y equals 2x minus 7. I can now substitute this into the other equation. So I know x squared plus my y value squared, my y value is 2x minus 7, equals 34. Multiply out the brackets, which is going to give me, so this part here, 4x squared minus 14x minus 14x plus 49. Therefore, if we collect like terms, say 5x squared minus 28x plus 49 equals 34, and now make equal to 0. So taking away 34 from each side, so 5x squared minus 28x plus 15. At this point, we now want to use the function on our calculator that solves a quadratic equation. So a value equals 5, b value equals minus 28, c value equals 15. So that's mode 5.3 on the calculator. Sub in the values and you get x solutions equaling 0.6 and 5. I now want to go back to the original equation I set up for y. So I said y equals 2x minus 7. So when x equals 0.6, y equals 2 times 0.6 minus 7, which gives me a y value of minus 5.8. When x equals 5, y equals 2 times 5 minus 7, so y equals 3. Okay, so these solutions come in pairs. So we've got x equals 0.6, y equals minus 5.8, and x equals 5, y equals 3. In order to calculate the height mt, well, first I'm going to do Pythagoras' theorem on this triangle here. I want to calculate the length AC. So AC squared equals 230 squared plus 230 squared. That bottom triangle is a right-angled triangle. That will give me a length AC, the square root of 230 squared plus 230 squared, which equals 325.2691. Now, keep those values in your calculator, so do not leave it as a rounded value. MC is now half of that value, so half of 325.2691, which gives me 162.6. Okay, keep all the values in your calculator. Okay, I'm now going to consider this triangle here to work out TM. Well, again, using Pythagoras, 218 squared equals MC squared, so 162.6 squared plus TM squared. To make TM the subject of the equation, I rearrange, say 218 squared minus 162.6 squared. So in order to work out TM, well, I do 218 squared minus 162.6 squared. Remember, keep all the values on a calculator for 162.6, whatever it may be. Then square root, and it gives you a value of 145 meters to three significant figures.